Good day to you, my dear friends. Well, it's time to solve some LeetCode problems, yay! But I had an job interview like 5 minutes ago, so I'm so tired of talking. Ooh. Still, we have to solve some LeetCode problems. And I want to start with my mistake yesterday. I told you that this problem about anagram can be solved using this solution, and nothing can be further from the truth. Yeah, it doesn't work, but I was too excited to notice that it doesn't work. Of course, we do not want unique here because we want to take repetitions into consideration too. Just sort would do, and this is a nice solution. Now I want to discuss with you a good old problem about rectangle that I tried to solve for 5 days and was successful, and I already explained my solution like 2 or 3 days ago. You can find this video. Now I want to show you the best approaches to this problem. Luckily we have an editorial section here, but it's in Java or Python, so we are going to adapt the solutions to Ruby code, because Ruby section here in solutions, well, there is just one solution. So let me remind you, what is the problem? Well, we have a lot of points and we want to know what is the minimum area of a possible rectangle that we can create using these points. And as you probably remember, I started with creating a hash, and in this hash I added all these rows. For example, if some dots have y coordinate 5, and there can be many dots, they all go to hash with key 5. You're gonna put all this x coordinates, I don't know, like maybe 2, 4 and 5. This was the start of my solution. In editorial they use similar approach, but they use columns, not rows, so they use x coordinates. Let's also do that, why not? So let's say we have a hash, and let's iterate through our points. Let's say hash point 0, because x coordinate goes first. And we're gonna add point 1. right? So we have as keys, we have x coordinates. As values, we have y coordinates now. These are our keys, and we can check that we have columns 1. Here is it. What the hell? Oh no, it's still rows. So we have y here and then x. Oh no, this is the first one. Yes, now it's right. 1, 3, 2. Great. And if we check the second case, we're gonna have 1, 3, and 4. See? Beautiful. And in values we have y coordinates. It's a first one, so we have 1 and 3, 1 and 3. Here 1 and 3, 1, 3, and 2. And in second test case we're gonna have the same 1, 3, 1, 3, 1, 3. Yeah. Now we want to sort them. Not them, we want to sort keys. So that we start from the leftmost column, this one, and we're gonna proceed to the right. Sort each do how do you want to call it? Let's call it x1. We sorted keys, we take the first key, and from hash, using this first key, we take all the y coordinates, and we call it column. Okay, good. Now let's iterate this column. Maybe it will be better to use while loop here. Let me think about it. Okay, let's use while loop. So let's say okay, it'll do. While we have elements in our column, let's also introduce another index, I plus 1. What do we want to have here? Column I and column J. Let's say we have this column of dots. Oh, and by the way, let's also sort. Let's make it more readable. Let's say that y1 is column I, and y2 is column j. Then here we can use just y1 and y2. So what is going on? Let's say this is -5, -4, -3, -1, 1, 2, 3, 4, 5. And we start with -5. I is this -5. Oh, it's not I -5. In our case, I is 0, of course. You see? But when we take 0th element from column, we get -5 because it is sorted and we take the first element. So we get this -5, it's our y1. And then we go through every other point For example, y2 is a -4. And we need a new hash. We want to call it, as I usually do, pairs. Okay. Now we want to check, do we have this key? In our hash. If we do, that's one story. But for now, we do not have anything. If we do not have, we want to add this key to our pairs hash and also value. And as a value, we want to add x1 because we want to remember what is an x coordinate of this pair. So of course we're gonna get every combination of these dots, every pair, to this hash. But then we go to the next column and do the same thing. We create every possible pair. And then we check if we already have this pair in our hash. It means that we have the same pair in previous column. And that means that we can make, for example, if it's -5 and -4, we have it in both columns. So it means that we can make a rectangle out of it. Huh? So let's call it area of a rectangle. We have these two. And in our case, because they are sorted, do we want to sort this too? Not this. Well, yes, it's sorted for sure. So y2 definitely is bigger than y1. What do we have here? Well, we know current x, and we want to take value from our pairs of the previous x coordinate, and this is our area. Probably we want to replace this. So I'd say we want to do this every time, nothing else. Because we want to update. Update the value of this key. Because if we're gonna encounter some other x's with the same pair, for example -5 and -4, we know that this rectangle is smaller than this huge rectangle, right? So we need to replace this x coordinate with this coordinate. If you know what I mean. Oh my god, there are so many dropped frames. It's probably impossible to watch. So many drops. Yeah, I have a bad connection today. And I do not have any viewers to tell me that my connection is bad. Oh, this is awful. So maybe I'm telling it's fine. Strange. I lost like 2000 frames, but okay, if this is okay, then we continue. Well, thank you very much for clarifying this. So we have this area. How do we know if we need the smallest area? Minimum area rectangle. So we're gonna make a new variable. Let's call it min area, for example. But what value do we want to use here? I found a new trick. Let's try to do this. It's called float. I don't remember. Maybe infinity, maybe infinite. Let's see. Well, it didn't break. So when we use this infinity, we get like the biggest number possible. So any other number is going to be smaller. Now we want to compare our new area with this minimum area. Like this. What do we want to do in the end? Well, we want to check if min area is still infinity. Then we want to return 0 because this is a condition. Otherwise we want to return minimum area, something like this. Oh, it's green. But runtime, it's ugly. This is an ugly runtime. My runtime was a lot better. Yeah, it's pretty much the same. Let's try the solution by this dude. And to tell you the truth, I like my solution more because it's definitely faster. Let's see what it's gonna give us. Oh yes, because you know at some point you do not have to do this anymore, but this is only in my solution. So go back a few days before and you'll see this video. Well, I do another solution, but that's an editorial solution, so what can you do? By the way, this solution about columns is not the only solution that they propose. There is another way. Let's try to reproduce this way too. So let's say we have 2 points. Let's say we have a point, well, okay, -5 and -4, and we have a point, I don't know, 1, 2. And we think about these points as a diagonal of rectangle. Well, in my case, it will be better to do this the other way. So let's say this is -5, -4, and this one is 1, 2. And we want to check if in our points we have another 2 points with coordinates, like we're gonna take -5 from here, and let's say not -5, well, it's an x, yes, -5 and 2. And here we want to check if we have 1 and it's -4. If we have these 2 points among our points, then we have a rectangle, and we can calculate its area, and we can compare it to areas of other possible rectangles and find the minimum one. And that's kind of interesting. How can we do that? Let's say, well, they propose to use set, and that's quite a rare thing in Ruby, but let's do this. So let's have a set. Let's turn points into a set. What is a set? Well, it's like a combination between a hash and an array. I don't know. So set has every element only once, but that's not why we want it, because we have unique points. From set we can take any element in big O of 1, just like a key from a hash, you see? So let's turn points to set, Is it gonna work at all? I don't know. Well, it just doesn't know what is set. It's alright. Now let's do the same thing that we did in our previous solution. 2 while loops. We want to collect every possible pair. I think because we do not have this solution in Ruby, we have only one solution here, so I hope we are correct. Let's not call it I. Well, let's call it I, but here let's call it something like 0.1 and 0.2. And we want to find 0.3. It's gonna be equal to what? We're gonna take let's say x coordinate from point I. No, wait. From point 1 I wanted to say. Yeah. And let's take y coordinate from point 2. And let's check if we have this point in our set. How is it done? I don't even remember. Probably just like this. Do we have this dot? Let's also do 0.4. It's going to be the same thing, but we're going to take x coordinate from point 2 and y coordinate from point 1. And if this is the case, what do we want to do? We want again to calculate an area, and it's gonna be, well, they're not sorted. Maybe we want to sort everything, I'm not sure. Who cares, let's just do absolute values. Have these 4 points. Oh, it's quite easy. So you want to take point 1 y coordinate. Now let's subtract point 2 y coordinate, y coordinate. Let's do absolute value. And the same thing, I guess, for x coordinate. Oh, I'm so tired today. You don't even need this, you just want to know if they exist. So we can just well, we're gonna do this later. Let's check for now. We want to do absolute like for whole thing. Nice. And of course the same. Our new trick, float. Oh, infinity, of course. Here is it. Infinity, float. So many typos. And min area is gonna be equal to min area min, and the same ending. Min area equals to float infinity 0 or min area. And I don't know if it's gonna work at all. It's all very theoretical. It's wrong. Okay, we have an extra bracket somewhere. No. How do we check if something isn't set? Let's maybe something like include, I don't know, Ruby set. I love this because it gives me an opportunity to test all these new methods. So set. Subset? I don't know. What does it do? Nah. How do we check? Include? Yeah. Set include I don't know. Maybe sets in Ruby doesn't have the same qualities as sets in, say, Python. We're gonna find out. Time limit. Because of this, we forgot to add J somehow. Great, but it's wrong. Why is it wrong? Minutes area. Okay, this condition doesn't work. Ruby, how do we check if element is in set? So set doesn't work the same way. That's interesting. Do we fail this check somehow? I want to make this work. I'm just curious. Let's create array areas. What do we have here? Now, how come we have 0? Oh, of course. We want to check if these two dots, of course, like this one and this one, that they do not have the same x coordinate or the same y coordinate, because if they do, that it's not a diagonal, it's a vertical line or horizontal line. That's what failed us. Okay. And the same for x coordinate. Let's see what we're gonna have now in this array. Just fours. It's the first test case. Okay, still not optimal. Still my solution is the best solution. I think. With this solution I think, what? Oh yeah, that we may hit a time limit, actually. Of course, it's so long. Let's see the editorial. What do they do? No, it's the same. It's like we well, maybe they don't, but here we check that these points are in set, right? If they don't go one by one, how they find these 2 points for the diagonal? They must go one by one. And they're not even sorted. Nah. The problem here is that maybe we already have a very small rectangle, but we still do this, all this. Yeah. We want more conditions. already we can count the area here, you know. And if this area yeah, only if this area is smaller than min area, we want to do that. Maybe something like this. Oh, we don't need that anymore. You see, better. Still ugly as all hell. Where is my original solution? This one. No, not this one. This is modified already. This one, it's huge and ugly, but let's see how many milliseconds are we gonna get with my solution. I think for editorial solutions, both of these approaches are too bad. I need to, to refactor, to update mine and post it in solutions section. That's it. But also I want to quickly solve something simple today, because every day we must solve something new, and this is an old problem. Maybe an easy problem at least. Maybe even a JavaScript problem, huh? Because I remember there was a JavaScript problem. If we sort by easy difficulty and by acceptance, on the first page we have this problem, interval cancellation. Interval cancellation. So we want to set interval and then cancel this interval using closure. Now we have a similar problem somewhere here. Let me see. And I think it's gonna have exactly the same solution. So this is interval cancellation, and we have timeout cancellation. Oh boy, oh boy. Sorry. That was loud. It was the same thing, but there was a timeout, not interval. So we're gonna do exactly the same thing, I think. It's like we want to create a, let's call it, where is it? Let's call it interval. I don't remember the syntaxes. Probably something like this. We're gonna have an arrow function, and we want to return this function with arguments, and we want to set a timer. So we have an interval. But to create a closure, we want to return a function. And in this function we are going to, what is this? What is this end? I'm going to do clear interval. Let's give it an interval. Something like this, I guess. Let's check. Nope. Oh, I see. Should be called immediately. So we want to call this and then do all that. Better. Why doesn't it work? Doesn't make much difference, I think. Yeah, it's even worse, of course. So. We call it immediately and then no, it can't be like this. Yeah. So what is the difference here? Here we have one element in array, here we have 2, 3. So oh, probably no. Okay, it should be called immediately. That's what we do. Why doesn't it work? Maybe something like this. So we call it immediately. Broke something. This is so strange. What? What was that? How is it different? It's exactly the same. Something is wrong with that counter. Oh. So let me check again. If we do run, now it's all green. Okay, who am I to argue? Such a strange day. What can I say? Charming world of JavaScript programming. But now, unfortunately, I have to go. I have to run. Thank you, my dear friends, for being here with me. We're gonna continue tomorrow. Again, so many drops. Yeah, my internet connection is bad today. I hope it was viewable, let's call it like this. So thank you very much and goodbye.